World. Colby's 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 World. Like that. Speaking of vectors, we are here today to talk about a very important vector, force. Force is a vector. It has magnitude and direction. Force is an action exerted on an object which may change the object's state of motion. State of motion? What is that? Well, right now, as you are watching this, your state of motion is probably at rest. You are likely not moving. You are at rest. If you want to change your state of motion, how do you do that? Well, you need a force. That's how. You are going to need some sort of force to push you up out of your seat. Eventually, you will use your feet to push against the floor, and the floor will push back against your feet, causing you to move upwards. Then your state of motion will no longer be at rest. You'll be moving. Force is that thing that can change your state of motion from being at rest to being in motion. And what about an object that is in motion already? A car driving down the street, for instance. The car's state of motion is in motion. It is moving down the street at a constant 40 miles per hour. Then it comes upon a stop sign. How does the car stop? If the car stops, its state of motion would be at rest. It takes a force to stop the car. The driver puts on the brakes. The wheels of the car put a friction force on the road, and the road pushes back against the wheels, causing the car to stop. The force of the wheels caused the car to change its state of motion from in motion to at rest. So, what is force anyhow? You already know what it is. Imagine that you had to explain force to your younger sister. How would you explain force using simple words? Well, a force is a push or a pull. It's that simple. A push or a pull. And those are the only two things that forces can do. They can push or they can pull. Force is a vector. It has direction and it causes acceleration. If I push you to the left, you will accelerate to the left. If I push you to the right, you accelerate right. Gravity is a force that pulls you down, so you accelerate down. Force has direction. It is a vector. How do we measure force? We use Newton's, of course. Newton's laws of motion are all about force. They may as well be called Newton's laws of force. Scientists have decided to honor Sir Isaac Newton's discovery of the laws of motion by using his name for force. Newton's is force. Force is Newton's. In order to better picture what a force is, let us look at some examples. There are two types of forces, contact forces and field forces. Contact forces mean that the two objects are, they are in contact with one another. They are touching. Most of the forces that we think about are contact forces. Earlier we mentioned how you are at rest. Right now, your state of motion is at rest. You are sitting at a computer watching a video. In order to change your state of motion, you will have to push against something to get out of your seat. Your feet will press against the floor. The floor will press back on you. This is an example of a contact force. The force is in contact with your feet. Well, maybe you are wearing socks, so your feet are in contact with your socks, and your socks are in contact with your feet. But your socks are also in contact with the floor, and the floor is in contact with your socks. But you get the idea. It gets a bit more complicated if you are wearing shoes around your socks. Let's just say there are a lot of contact forces going on to actually push you out of your seat. You are in contact with the seat, for an example. If you are taking notes, you will use a pen or pencil. Your hand is in contact with the pencil. When you move the pencil around, you use a contact force. Also, the pencil is in contact with the paper. That is another contact force. Most of the forces you think about are contact forces. The other type of force does not require contact. The objects may be in contact, but they do not have to be in contact. Forces that act through a distance are given a special name. They are called field forces. For now, let's keep it simple and just say that a field is invisible and you cannot feel or touch a field. However, when objects are in the field, they can be affected by the field. Can you think of forces that act through a distance that do not require the objects to be touching? There are 3 types of field forces. Forces that do not require the 2 objects to be in contact with one another. The first force that students think of is the one that is most noticeable every day when you jump in the air, throw a basketball, or drop your pencil. This type of force pulls things down. It also happens to be the same force that keeps the Earth in orbit around the Sun. The same force that keeps the moon in orbit around the Earth. What is this force? Yes, gravity is the main field force that affects all things near the surface of the Earth. And it affects them all of the time. We say that there is a gravitational field around the Earth that tries to pull all mass towards it. You cannot touch or feel the gravity field, but it does affect you. You will become very familiar with the gravitational force in your studies of physics. Gravitational forces are very important. One of the other field forces I am sure you have come upon in your life. You may have played with these when you were a kid. When you move them close together, they either pull or jump away from each other on their own, almost like magic. Many people also like to use them to hold things to the front of their refrigerator. What is this force? Magnets! Yes, magnetism is the second type of field force. The Earth also happens to have a magnetic field around it. This magnetic field is what causes compasses to point north. Some animals, such as bats and sea turtles, use the Earth's magnetic field to help them navigate. The third type of field force might be a little tricky to figure out. It is electric force. All electric devices produce some sort of electric field around them. Your cell phone operates by being in the electric field of a nearby cell tower. The human nervous system is partially electric. In fact, some animals, such as sharks, are able to detect the electric field of other animals even if the animals are hidden under the sand. Yes, physics is everywhere, even in your nervous system. Knowing the basic types of forces will help you later picture these forces and will allow you to see the effect of various forces on all the things around you.